Alrighty, so for today's lesson, we're going to be talking about complements and Venn diagrams, so set stuff again. So the deal is that set A is considered to be a subset of B if every element in set A is also an element of set B. So here you've got set A and there's 3 numbers, 2, 4, 5. Then you've got subset B and there's 5 numbers, 0, 1, 2, 3, 4, 5. So is set A a subset of B? Well, let's see. There's a 2 in A as well as in B. There's a 4 in A, there's a 4 in B, and there's a 5 in A, which is also in B. So yes, set A is a subset of set B because every element in A is found in B. The next question is set B a subset of set A? And here what's happening is, okay, I've got the 2, I've got the 4, I've got the 5, but I'm missing the 0 and the 3. So this would be no, because not every element from B is in A. So that should be pretty easy. For the next thing that we talk about, if I can get down here, get to the next page. Oh, this is annoying. There we go. Okay, so the universal set. So that's a U, not to be confused with union from the other day. Right, so the universal set is the general set of elements. So it's whatever is a part of this particular set is going to be considered the universal set. The Venn diagram that we're showing you here shows the universal set U, represented by a rectangle, with subset A represented by the circle. Set A is a subset of the universal set because the circle representing the elements of set A is completely inside the rectangle representing U. So this next piece, well, the next part, that's okay, let me finish with this one. So what's happening here is set U, let's say, is a whole bunch of cars. Set A are all the cars that are Hondas. This thing, which happens to be on the next page, this thing happens to be all the cars that are not Hondas. Okay, so we're going to call set A Hondas. A prime, this little prime thing, are not Hondas. And all of these guys are in the general universal set that we're going to call cars. So what happens is this next slide should really be on this first one that we're dealing with. And this is just going to drive me crazy. So complement of the set, this one right here, should really be on the page before. Okay, so the set of all elements that are not elements of set A are called the complement of set A, and it's symbolized with that A little prime in the diagram. So here's an example using complements. In the Venn diagram, the universal set are the numbers 1, 2, 3, all the way up through 10. R has the numbers 1, 3, 5, and 7 in it. S has the numbers 2, 4, 5, 7, and 10. So what are the things that are not in R? So R prime, this means not in R. And that would be, well, 2, 4, 10, 6, 8, and 9. Remember, 7 and 5 are a part of both, so you can't put that in there. Number 2, S prime, means what are the things not in S? And that would be 1 and 3, and then the 6, the 8, the 9. Okay. Venn diagrams come next. So construct a Venn diagram, show all your math work in a group of 18 kids. 3 are members of speech, 7 are members of drama, 2 are members of both. How many students belong to neither speech nor drama? You always want to start out with the overlap. So start with the overlap, or the intersection as we would call it from yesterday. So you've got this big old universal set, and you know that there are speech club, and there are drama clubs. So let's maybe call this one the speech. Let's call this one the drama. Well, we know that there are 2 people that are members of both clubs. So 2 is going to come in here. Well, if 2 is in there and we've got 3 members that are speech, we need to say what is 3 minus 2 because that's how many people are just in speech. Drama, we know that there are 7, which means I already have 2 people in drama already from my overlap, right? So then 7 minus 2 becomes 5. So right now, in either club, 1 plus 2 plus 5 equals 8 kids. 18 kids are in the group that we're talking about. If I subtract 18 by 8, then I'm going to get 10 students that are in neither. They could be in a different club, but they're just not in speech or drama. Let's try this next one. Oh, so frustrating. Go the other way, other way, other way. Here we go. 225 students attend a homecoming football game. 120 get soda, 45 get popcorn, 35 do both. How many students do not buy either? So I'm not going to put the rectangle in it this time, but I could. So here we've got soda. Here we have popcorn. And then we need to start with the overlap. So we know for sure that there were 35 that purchased both. So that goes here. We know that for soda, there was 120. So if I take the 120 minus the 35 that I have already, that gives me 85. For the popcorn, I know that there was 45 with popcorn, but 35 have already been included, which means there's 10 people that get the popcorn. Now all I have to do is say, all right, well, what's 85 plus 35 plus 10? And that's going to give me 130 kids. So if I now take the 225 at the game minus the 130 that purchased either soda or popcorn or both, I get 95 didn't buy either. So I guess if I want to put a rectangle now, a little bit messy, I've got 95 not buying either. All right, that's it. This should be pretty easy for you for the homework. All right, so good luck.